So, okay, so this is the loan prediction problem that we were looking through. And as usual, you import all the libraries on this one. And so this is you load the CSV file and read the head. This one just helps for you to know what data you have and the columns, the data contained in the columns and all that in the rows and everything. Then data.info gives you the column information. And this one also can help you know the range index, the number of entries. And so you have the data number of the columns contained, and also what the data type is, object, integer, float. And this one also you can kind of now see that eventually you will have to do data cleaning, because we saw that we have 614 entries, and some of these columns don't have a total of 614. So you pretty much can tell that, like gender, you have some missing values in that column. So that one will kind of off the bat tell you that you have some missing data. Then, so this one is the next process. You need to clean the data and fill the missing values before you do anything else. And I think we had looked at it different. So at this point, you need to know which columns and what is missing. And we use the data.apply and use the lambda so this is lambda x colon sum. So this is the method for calling or looking for now values in it helps you to check missing values in each column. So you call that, you put that and run it, and then it will give you, no, this is correct. What is this? Wait, let me run this from here because it's all right. So it gives you the columns and the total number of missing values in each column. So gender has 13, married and all that. And some of them don't have missing, so there'll be 0. The ones that are 0, it means all the values are in the data. So from here, this is now when you start filling the missing values on the columns. And we're going to use the value, the data, and then brackets, gender. So gender, you're identifying the column, you're specifying the column, and then value count. So it will give you the number of male. The total number is 489, and then female is 112. So as for filling the missing values, we always use the most frequent used value is what we are going to use to fill the missing values in the column. So in this one, we are going to,
I'm sorry, explain it further so they understand. Explain it to them. the male and the female. So if you do a comparison in the gender, for you to get, let's say that there was a null value somewhere, you want to get the most frequently occurring. Is that the mode? Yes. So you get the mode, and then use that to fill in. See the male, and then if you come to the, let's say the married and the unmarried, you'll find that the married are more than the unmarried. And then you use the married to fill in the blanks. I hope that,
and this is,
go ahead, I'm sorry. Yeah.
And this is mostly used like for string. When you have this, instead of doing a mean or because you can get the mean of male and female, so you're gonna end up going with the most frequently used the most frequently occurring value in the column. So in this one, it will be male.
Okay. Yeah.
So on the next, so you do data.gender. So data.the column is equals to data.gender filna. Filna is the method. So we see that it's
filling the non-applicable, the NA. So we're filling.
Yeah, the NA. Yeah. So you're filling the NA. The NA value will be filled with male.
Yes.
So it will go into that column and then look through, and all the NA values will be replaced with the male value in that column. And the next one will be, you go to the next column, and the next column is married. Do the same value count, and you get married, yes, 398, and no is 213. And the same thing, you go to the next cell and fill the NA with the married yes value, and all the NA values will be filled with yes, meaning they'll be filled with married. Continue to dependent, do the same thing, run the value count for the column, and then it will list down. So the zero dependence is the most frequently occurring, and the rest 1, 2, 3 will follow. So on this one, on the dependent column, we are going to run the fill now method, and it will fill all the NA values in the dependence column with 0, which will mean zero dependent. Next one is self-employed. And you make sure, okay, we are going to use this list to go down. It will guide you to go down all the columns that have missing values. So do the same thing for self-employed, value count. No, meaning meaning no, not self-employed is the most occurring. And run the fill now and fill it with no. And the same, so all the NA values will be filled with no. Go to the loan amount and do the same thing. Oh, this one is, I think, should be. No, this one actually is not. Yeah?
Yeah, I can see a lot amount is filled, but you have
no, that
there.
Which one? Loan amount? That was that was wrong. I think that one was not supposed to be there.
Which one?
So loan amount, there is loan amount and loan amount term.
Okay, for the loan amount, don't worry about it. Worry about the loan amount term, which we are going to get the maximum, which is between 360. Most of the people take loan at that rate.
Yeah, the highest term.
Yeah. So that's if you look at line 18, we bring it up, and then you see the highest amount is 512 to 360. So we use the fill NA line 19.
Yeah.
Fill NA with the value of the term.
Of the term, the highest value.
Yeah. Is that what Ruth is also saying, or because we are
No,
not?
I think she was saying there's the loan amount, and then there's a column for loan amount, and there's a column for loan amount term.
Okay, but right now what you're doing the data, you're doing the data cleaning, right?
Yeah.
But you're doing the data cleaning on the non-numerical values. The non-numerical values are are anything other than the loan amount. So we got rid of the loan ID. Loan ID has nothing to do with our prediction.
Oh yeah.
Yeah. So we went to the gender.
Loan ID, I think, is generated by the bank or the company. So it has nothing to do with our database.
Yeah. So we basically, we are looking at the non-numerical data types. So we split them. If you go back, you'll see that we used, let me see, we did the separation of, let me go back here. There with me one second. We did the separation. Okay. Okay, we did the separation of the numerical and the non-numerical.
Categorical.
Yeah. So we did the categorical, right? And then in the category, okay, if you look, we have all the categories now split. The loan amount, the loan amount, the credit. Go ahead.
No, I was looking for the categorical, but continue.
Okay. All right. So we have to, if you were given a data set, you probably want what we call separation of concerns. We know our goal here is to get the prediction, to see based on the problem statement. Okay, we are getting to see are the most loaned people, and let's say, are they male or female? Are they married or unmarried? Are they within the city limit or outside the city limit? So in that case, you really don't have anything to do with the loan ID. It could be from equity or it could be from commercial bank. We don't care. We have a data set. We only care about the income on the numerical side. We care probably about the income of the individual. We care about the co-applicant income. Remember last time I used me and Emily as an example. If Emily is going for a loan and maybe she thinks she need a co-applicant, then she dragged me along, then my income will also have to play to be able to determine if she can get a loan. And also, when you talk of the loan amount term is the number of years. The number of years they're gonna be getting that loan for. And the most common one, over 500 people normally go in our data set, they go for 360 loan. 360, you divide by 60. I believe that's gonna be about 3-4 years, maybe not, but it's around that. And then the credit history, that will determine whether this person is credit worthy, and can we trust them with our money. So the credit history, the loan amount, and the loan amount term, those are the co-applicant income, the loan amount, the co-applicant, the applicant income, the co-applicant income, and the loan amount. Those are very, very critical in this respect. They are going to fall under the numerical. But when we start cleaning the data or the data set, first of all, if you go back all the way up there, Emily, where we got rid of the loan ID.
I think at this point we had not. It comes.
We dropped it somewhere.
Yeah, we dropped it from here.
Loan ID.
Wait.
Then we started cleaning the data column by column, remember? Column by column.
Oh, this is, yeah, here.
So we dropped it there, okay? And then we did what we call categorization. So we said we want the categorical columns, okay, to be given gender, married, dependent, education. That's one category. And then another category is just the numerical column, which is going to be the loan amount, the co-applicant income, and the income, the applicant income. Okay. So I think that explains it, right? Ruth, are you clear on that?
Yes, yes.
Thank you. Let's go ahead, Emily.
So the credit history was the last one, and we do the value count, and we found that the credit history of 1 is the most frequently occurring. So we do the fill NA with 1.
One means true, and 0
true, yeah.
So most people
means false. So
their loan tend to fall under the majority. They pay more.
Yeah.
Tend to pay yes. Okay.
So we run the lambda, there is now, and we find that all the values now are clean. All the columns are clean, there's no missing. No missing values.
Yeah.
And I think, wait a minute. So after that, and we do the header, the data.head, just to verify that we do not have any, because we had one here. I think when we called, let me see, when we called, we did the data header for loan amount for the first row was NA.
Yeah. So
note that
NA for the loan amount, that if you leave that without being removed, you remember last time we had an issue, and therefore that's why I say, hey, let's go ahead and in our Sunday class, let's go ahead and do the cleaning.
Yeah.
Okay. Okay. Thank you.
So we'll come now to splitting the training data. So we are splitting data. We are splitting our data into X and Y, and X is, or even the other names they give it is splitting the features and target. The features and target. So X will be the features and Y will be the target. So we use the ilog X and make sure that X is a capital, it's an uppercase X. And I don't know whether, George, you can explain that, or it's just, that's how it is.
Oh, that's just a variable. So just, you probably want to make sure you distinguish those, otherwise you'll be overwriting stuff.
Okay. So, and X will be X axis and Y will end up being the Y axis.
Right.
Yeah. So you start from 1, the index 1 to 12. Those, so column index 1 to column index 12 will be the features. And so this one will contain 1 to 12. I believe 1 to 11. The indexes, when we count our indexes, they start from 0.
Yeah. So remember the target, we don't count it. The target is going to fall under the Y.
Yeah, so the Y will contain the last target, the last column, which is the target.
It's number 12. Right?
And so when you run that one, and then on here you call X, and it will print. They'll print as array. It's an array, and it will list. It will be a list of all the values in that row. So every row will be an array.
So let me explain this part. So say male, okay, no.
Yeah.
Or they are in the urban area. That's the first row. So we say, oh, this is not a male, and therefore they are living in the urban, and the one which is there is telling us whether they if you go back up again, I'm sorry, go back up. It's where we got a 1 and a 0, where we got okay, keep on. Okay. Again.
Which one? We haven't. Have we done category? We haven't encoded.
I explained where the 1 and the 0, the true.
Oh, this one, the credit history.
Yeah. So the credit history, if it's a 1, then now go back down. Now, I'm sorry, go scroll down, so I can explain the array.
Oh, back to okay.
Yeah. So here we are being told that this person is male, and then we are saying no, it's not, and then we are saying 0. Okay, this person for a 0 depend on whatever is in that. We start with male. Let me go look at my.
Yeah, let me that way.
Okay.
You can see the.
Yeah. So if you scroll on the left, scroll on the left. Okay. So you can see the male is the gender is male, right? And the married, they are not married.
It's not.
And they don't have no dependents. And then known, we are going to give them a term of 360. Okay. And then look like the credit history is good, and they live in the urban area. One is also male, but they are married, they have dependents, the loan term is 360, their credit history is also good, and they live in the rural area. So this X here is going to help you to be able to determine. You can actually read. If you're a loan officer, you can be able to determine whether to give this guy a loan or not. But before you do that, now the Y will be the target. The Y will determine either yes or a no. So if it's a yes, we can give them a loan based on their credit history, the number of dependents, their income, their co-applicant income, and stuff like that. So that's where you get line 26. It's explaining that in an array format. Okay.
Yeah. And this one gives you the list of all the 600, I think, all the rows. All right, on line 27, we'll be splitting the data set into the training set, into training set and test set. And we are going to use the sklearn model, sklearn.model selection, and then you import train set split. And we are splitting them into X train, X test, Y train, and Y test. So do that equals train test split. And it's into X and Y. And the test size is 1/3. In random state is 0. So the test size is 1/3. So the train size will be 2/3, right? And always we've been told that the test size should always be the train size should always be the bigger size than the test. So we are always going to have the train size to be bigger than the train. So let's scroll. Run that. And then 28, run the X string, and it gives an array of rows, male, yes, and all that. It goes to that. And 29, now we come to the encoding of categorical data. And the categorical data is also known as the independent variable. And from the sklearn.preprocessing, we are going to import the label encoder. And we run the encoder, label encoder underscore X equals label encoder, and put the parentheses. So you run that. And we go to the for loop. No, range, for range. No. So we say for I in range 0 to 5, the X string is, I think, 0 to, it's the I, this I is equals to label encoder underscore X. We are fitting, we'll fit and try to fit the transformed data into X underscore train. And the X train into what? Index 10 equals to,
yeah.
Yeah, equals to label encoder underscore X, the one, this variable, and we'll feed the transform X string.
Yeah.
10. Uh-oh.
So run the ones up the top first.
Oh, this one, sorry.
Then run this. So this way you are saying, because I remember.
Oh, I think I didn't run.
You probably want to start all the way from up.
I think, from up?
No. I mean, from wherever you left, because it has to feed into each other as they go down.
Okay, let me start here.
Okay, go back. Let me see, what's the error? What's your error? Let me see your error. Scroll down. Okay, argument must be a string or a number. Okay. Okay, at that point, let me take over, right?
Okay.
Because mine is running. And I think,
okay.
I think your code which made it run last time. Running.
Oh, yeah. All right. Let me stop sharing.
Okay, so let me go ahead and share my screen. Okay, so whatever Emily was showing me is up to here. So we know some people live in the rural area, some people live not in the rural area, but somewhere between the urban and the city. So we call them semi-urban. And there we categorize them by male, whether they're married or not. Okay, and then this line, we also know whether they have dependents or not. And this is the long term. Okay, like how many years of their long term. And then this is their credit history. If they have a 1, that means they have good credit history. If they have a 0, then that's not good. Okay, so we come here and then we do the encoding of the categorical data set. Okay, we now have the 2 data sets, which are the independent and the dependent variable. So let me ask team members here, what's the independent variable? Anybody, please? You guys are funny. Maybe somebody's talking on mute. What's the independent variable? If you remember, it's okay.
Independent.
Yes, but this is something we talked about several times. Somebody,
The features.
okay. Now the features. What does that mean, Esther?
It means that they always remain constant.
Okay.
Like
And those are
they're
the
the ones which influence the independent ones. Like they're always the same. They never change.
okay.
They are
So
the categorical.
okay, so those are the categorical, and they always you want to say this. They are the components in the x-axis. Those
Okay.
are the variables which help us to determine what output we're going to go in and run around. So the independent variable, as you can see here, is actually the x-axis. So um, so when we look at those, okay, these are all the variables, the x-axis. They are going to help us determine the y. This is the dependent variable. Okay. So when we do that, we go here and import Skyline preprocessing, but we import the label encoder. Okay, these are the libraries which are part of the Skyline library. So we go ahead and click on that. It's imported. And then we have a range. Now, if you remember from your introductory Python, we did the for loop. But the for loop is a range from 0 to 5, which is going to be from 1, 2, 3, 4. Okay. Now, we go ahead and do the training. Our training data set here, we take the variable I, and then we do the label encoding. We fit. When you say fit, that means you're training it. And then you transform it, and then you import it into x_train. Okay. Whatever we got there, we are going to go ahead and use it here. We transform it again, but now we label encode, but we only do for the 10. The 10 columns. Okay. Now encoding the dependent variable, that's going to be your target, the y. See here, this is giving it away, ladies and gentlemen. This is giving it away. That's the y-axis. So we go ahead and, okay, of course, let's run that. Let me run this one first. It's not good. This one. Just run a few minutes. Okay, run that. Run that. Training data set. Okay, now it's running. Once it ran, okay, now we know inside this xstring we have some values. Now we encode the dependent variable, which is the y, based on what we got from the x. Okay, the x is the input, the y is going to be the output. So we are going to go ahead and get whatever we get in the y_train. And now whatever we got is going to be saved in this value here. This is a variable y_train. Now remember what we got before was x. So let's go ahead and see what the x is. So the x is giving us the number 1, 1, 1. So 1 could be for male, depending on what you want it to be. So this could be for male. Okay. If you look this one, the corresponding one, 1, 1, 1, 1, 1. Look here. 1, 1, 1, 1, 1. So female is 0, male is 1. Okay. If you look here. So why do we do that? Because we know if we go by the word male, we might not be able to get something we're looking for. So we transformed that. We transformed, okay? Male to 1, female to 0. Okay? And then you can see yes to, transform yes to 1, okay? No to 0. This will remain the same, okay? This will remain the same. This will remain the same. And the target, I mean the rural, it's going to be 0, okay? And the semi-urban is going to be 1, and the urban is going to be 2. So that's the transformation. Once you do the transformation, now you go ahead and display or echo out your white train. So to the white train, and the white train is going to help you know the numbers now. 1 for male, 0 for female, okay, in that order. Okay, once you get that, remember, if it's a 0, the Y means we don't give the long. But if it's a 1, means we give the long. So this could be all the values we have of all the customers. Okay. Remember, we had like about 600 something customers. If you count this, they're probably gonna be the same. So this, you can multiply rows by columns to get the total. And then just remember this one you add. So once you go ahead and do this, we are going to go ahead and encode categorical data, encoding the independent variable, which is the X here. So we do the skyline, we import, we do the labeling. One hot encoder, we save it in label encoder, and then we do another range. So whatever you see here is actually the same thing we did up here. But now we are just expanding it a little bit more. Okay, so we did one for independent, and then we did another one for dependent. So we run that, and then we do the test, the X test. Remember, it's the X, which is the independent variable. So we run that, we got that. Okay, male 0, 1, 0, please. Let me see. Okay, this one is male, right? Yes, it's 1, 3, 360, 1, rural. Rural is, found out the rural is going to be 0, I believe. So the same thing here, when we do the encoding, it's going to be all here for you, for the y-axis, for the x-axis, which we're going to be able to feed into the y-axis to give us the features. Now, we import Skyline again, okay? So we do the importation. Now here, we import for standard scalar. We do the standardization, okay? SC is just standard scalar, it's a variable. We train the data set, we do the fit for transformation fitting on the X train, and also we do the on the X test. Okay. Now once we do that, Emily, what did we find out to be the meaning of this work? I forgot, right? Let me look it up. I'm just afraid you guys are not reaching out enough. I know you're busy, but reach out. I mean, I kind of like spend a lot of time with Emily and Esther, but I know everybody you need some help, unless you're a genius in this thing, but you didn't tell us.
It's principal component analysis.
That's correct. So this is a popular technique in machine learning, right? It relies on the fact that many types of vector space data are compressible, and that compression can be most efficiently achieved by sampling. Okay, so we add that. Okay. The added benefits of PCA are improved data visualization, which we are going to see here shortly, on optimization of resources used by the learning algorithm. So let me go back here. I'm going to go ahead and put that in text. Okay. This is as good as it goes. So once you do that, yes, cement it. So this one will explain that. Now, we are applying the PCA, the principal component analysis. So we run, but remember, we had this, and we had that. Okay. So we are going to, this is our function. We are going to go ahead and feed it in. Okay. Once we do that, now we are going to do our classification. Now the classification, remember, we have different types. Among the top, we have KNN, logistic regression, we have Bayesian, we have random forest, and we have binary random forest, and we have decision trees. Okay, so here now we want to do the regression, logistic regression. Now, why do we have to do this? Whatever we had in the data set, we don't know. But what we are trying to do is to get what's the best fit and at what percentage. We will be doing 4 classification analysis based on the 4 classification algorithms. The best one is what we are going to pick. Remember, you are the data scientist, so you have to convince the management based on your informed decision. Okay, so here we do logistic regression. How do we do that? We have to import it. So fitting logistic regression to the training data set. So we import it, we do the classification. Okay. When you do the random, that means you want to stabilize it so that it does not change each time you run. And then we do the classification, but we do the fitting by training it. Okay. So we run this, and this of this. This might not mean a lot, but it means something. If you really want to know, go and Google what logistic regression function is going to return. C for what, class weight for what, dual fault for what, fit intercept, true or false. All this will be explained for you. Do additional research on your end, so it's going to help you. Now, once you get that, now we are going to predict the test set result. Let's go ahead and do it. So the classifier will be able to feed into the Y. Remember, the Y is the dependent. So we print out the Y component. And those are the ones. Pretty much everybody right there is going to be qualified. I guess based on the credit history and their income so far. But remember, this is just a small sample. Okay? We don't know, but this is what we are seeing. And then now let's go ahead and measure the accuracy of that. We just did the prediction here. Now we want to measure its accuracy. So to measure the accuracy, we import against Scikit. And then we do the accuracy of logistic regression. So around that. And our accuracy here is at 71%, which is not really bad. But we are going to compare. Normally, remember, all this depends on what you're given as the data set. So once we do the measuring of the accuracy, we want to do the confusion metrics. What is confusion metrics? We want to know if this is going to be true positive, is it true negative, false positive, or false negative. So we do that here. So CM here means confusion metrics. That's the survival. And then we clean that. So remember your confusion metrics here will be 2 negative, 2 positive, 60, whatever they are. You can do this on your own, really. You can just, let's say, confusion metrics table. Okay. If you had, let's say, something like this. Okay. So here, take the line like 0 in my array there. It's going to mean true positive. 0 true positive. There are no true positives, okay? And then for the FP, false positive. It's a lot of false positives. That means some data, those are like, they're giving us some of the results which we actually don't expect to be true. And then another 0 there is FN, which is false negative. Okay. And then we have this other one right here, which is showing 145, which is true negative. So, and I think I shared this also with you in some notes somewhere. You can go look, and based on that, you should be able to make a decision really on what needs to be done. We have a lot of true negative, and then we have a few false positive, and we have 0 true positive and 0 false negative. So once we get that, now let's visualize the data set. Okay? You could as well visualize this if you wanted, but this is good enough. But I know we had already done this such that we know how to do the visualization. If you go to visualize the training set result, this is looking complicated, but it's not. It's just importing, and then you do the X set, train, put them, and then you declare the X and the X2, the X1 and the X2. Use a numpy, mesh the grade, you import your stuff. And this one, we are going to go ahead and visualize the training set result. So we click it, okay? And that should be able to give us this one, okay? So here, it tells you what 0 is. 0 means danger. No, you cannot give them alone. 1 here probably means yes, this guy can be given alone. Now here, okay, it tells you what you can make decision based on. Okay? Now, that's the logistic regression. We just did the training set result. Now let's go ahead and do the visualizing the test set result. Okay? That was the training, now this is the test. Don't get them confused. So we run this one here. And we get our, you see this, they look alike, but no, they don't really look alike. If you look at this one, some of them are around this particular area. Depends on what the Y and the X axis is telling. Okay. And then that's it for the logistic regression. Now, that's under the classification which we call. So this is number 1. Any question before we proceed? Okay. All right. Let's go to the next one. I hope you guys are understanding this, because it's very important. The interpretation of the data set is very important. Just like the cleaning, you should be able to infer, you should be able to make your own conclusion based on what you come up with.
I have a question.
Yes. Go ahead.
In the scatter plot, can you like plot the X train and X test together? The X train, the training, the results of the why train and the testing? Like how do you analyze this plot?
Okay. So your question is very complicated. Can you simplify? How do you
Okay,
analyze?
when I
How
see
do
like okay.
Mhm. Go ahead.
Mhm.
Go ahead.
Let's go on. Okay, I'm asking. Okay, when I understand, like from plotting this regression, we get the training data. We see that there's a relationship. Like you can be able to see what influences the either a zero or a one, like no loan or getting a loan, and it's kind of the same, almost the same line of regression on the test, but can you now try and compare the results of the test and the training using a scatter plot, one plot?
Okay. So we can do that on a scatter plot, and that's what we just did. But your question is, can we combine training and testing on the same?
Yes.
Yes, we can. But it's not going to be as accurate because it's going to be a lot of overlap. So that's why we try to separate the two.
Mm, okay.
I mean, it's almost like you don't want to mix oranges and apples. You want them to be separate so you know the distinction, right?
Mm-hmm.
It looks like I'm not convincing you, Esther. Am I?
Yeah. Yeah. I get you can mix them, but please explain. Like, okay, when you see these graphs, the two graphs, what is the conclusion from the two graphs?
So the one, you see the key here? You see the key?
Mm-hmm.
Okay. One means
Yes.
one means you most likely will be able to get a loan. Zero means they most likely will not be able to get a loan. Okay?
Mm-hmm.
So this on the training that, and then on the testing data set, we have like we have also zero on the red, and we also have one to green. But look, the scale here could be in the tens of thousands. So if you see like a green here, that means maybe just a small portion were able to get that approval. Then quite a number of those people were not able to get the approval. They range in a particular area, which is probably between, let's say, 2 and 2. Okay? Is that clear?
Yeah.
You sure?
Yeah.
You can always revisit it. Okay? If you want, I can also send you a copy of this. For those who want. This one I will not send, but if you request, I will. So here, we are going to go ahead and now look at the KNN, the K nearest neighbors, the model. Remember when we did this one, when we did the logistic regression, our accuracy was at 70%, which is actually 71, because this one is, you can kill this one and then we add it. So this is 71. So let's go ahead and do the one for KNN and see what we have. Okay. This is a very slow process. It's not like you just want to boom and then you get 100 and then you're done. You have to understand it. It's always going to be back and forth. The way Emily showed you how we cleaned it. You clean data set like that. You clean it. Maybe one day when you get a chance and you learn another language known as R, R will also shine more light. It comes with its own function. It's also very user-friendly, but a little bit harder to learn compared to Python, but do a lot of statistical analysis with R. So here, KNN, okay, nearest neighbors. We're going to go ahead and run that. So first of all, we import. There's something called the K nearest neighbors. We import that and then we do the classification. But remember, we are not doing the Euclidean. We are using the Minkowski. This is like the Manhattan distance, okay, with a p-value of 2. What is p-value, Esther? What is this? Remember you explained it last time. Can you explain it again?
The p-value is the number of variables we are testing, like whether for the outcome. Like in this case, we have 2. It's either yes or no. The outcome, yeah.
And can you also explain why do we have to choose 5? And why 5? Why not 4 or 6? 4 or 10 or 9?
We have to choose 5 because it's an odd number,
Yeah.
and because of how the model itself works, it chooses the best, like the number of the closest neighbors to that particular outcome that you're looking at. So in case, for instance, there's always a possibility that you might get two, you want to compare two of the values. So you need the odd number, makes it such a way that you cannot have equal values, so that you can either have one being more than the other. That always happens when you have an odd number. So it's easier to choose the neighbor.
Yeah. So you always want to, like, it's going to probably have a range of between 0 and 10. You always want to go for, don't go on the very low side. It might be noisy. Don't go on the very high side. It could be a lot of, you want to pick somewhere in the middle, like 5, but it has to be, try as much as possible, if it's okay, to make it an odd number. Okay. So here we do the Minkowski with a p-value of 2, but we get the K to be 5. Then we do the classification. And this is what comes out. Now, if you really need to know what all this means, you can go and Google that. Classifier, it's going to give you what the algorithm is, the leaf size, the metric parameter, the end jobs, the neighbors, the p-value, the rate. Okay, this is something you can do like in Google. So now, predicting the test result. We're doing the same thing we did with the logistic regression, but now we are doing it with predicting the test result. So we're taking that, and now we get our Y. Okay, this is going to be the Y, the ones and the zeros and the Y. So we got that. And then now we are going to measure our accuracy, okay, based on what we got there. So our accuracy here will be a little bit low. It's about 63%. Compared to 71, I would probably go for 71 than 63. So we have the KNN at 63. We have the LG, or LR, okay, at 71. So here we are making now, we are going to go ahead and do our metric, okay, confusion metric. So we run it. Remember, the previous one had zeros here. This was a 0, this was a 0. This was 145, and that was something like, I believe, 60 something, 60. Okay? So compare these two, and compare that. So when you compare that with this one, and then let me bring this, okay. Okay, so here, look at the numbers. For the KNN, the TN is 50. I'm sorry, it's 11. The FN is 27. The FP is 49. And the TP is 100. So you can tell that's a big variation. Very big variation. Okay, now, now we go here, we want to visualize the data set. We are visualizing based on the KNN. Okay, so we click on that. Some of them take a long time because it's doing calculations. So that's the that's the Google taking charge. It's not in my computer. Now look, it's taking like 23, 25, 26, 27 seconds, still going. If you're doing that on your computer, you probably grind to a halt. Okay, now you can see the KNN training set. Okay, we have the 1 and the 0s. Okay, and then we know the accuracy, it's at 63. Now we just visualized the training. Now we need to visualize the test. So we run the test. Takes long. Okay, and then takes longer. While this is processing, can I ask who tried this other than because me and Emily we did this, but did you guys try this? That was supposed to be our homework. Did we head anywhere? It's okay. I mean, I don't expect you guys to know everything here, but at least you tried.
I tried, but I used another example.
Okay. What do you mean another example?
Okay, I was still not sure about what exactly what, because I was confused about certain terms which I'm just getting to learn right now.
Okay.
Yeah, like I had issues with cleaning, so, and also splitting. Okay, for the other examples, I could do splitting, but I came to realize today that splitting was the same as features and targets.
Cleaning. Okay. I'm not really sure if that's accurate though. When you split the data set into training and testing. You get the categories, and then features, those are the independent variables you're going to work with. And then there's a target. The target is going to be the Y you are looking for. So when you do the X and the Y, you split. And then when you do the splitting, it has to be like a certain percentage, 20 to 80, or let's say 10 to 90. Well, in this case, we did 1/3. Okay. So what's 1/3? 1/300 times 100. 1/3 times 100. So normally you always want to make the testing as a larger data set. I'm sorry, the training. Is that? Maybe. What? I don't remember. I'm confused.
The training. The training is the larger one.
Try get the training so that you can train your data set. Do the training to be a larger data set and the testing. Okay. But again, when
could that be?
Go ahead.
No, about the training being the larger one, is that so you can at most incorporate all chances of, being training the data to all the extremes?
Yes.
When you put it in a bigger, there, okay.
Yeah. So you basically you really want to get all the possibilities. So you gotta train your data.
Mhm.
So you give it a bigger chunk.
Okay.
Mhm. So again, if you tried and you got stuck, just send me a note so I can see how I can assist. All right, so we got that. Did that come out? Yeah, this one came out. Now you see the training and then we see the testing. So this one is training data set. Amen. Then this one, so you can see there's a big difference. Okay, this is the training result, right? So this is training result. Okay, and then let's run that again. Training and testing. To break into this field, you have to sweat, cry, and bleed. It's not gonna be easy. I don't know if that makes any sense.
I guess because for me now it's much more. I can understand it. You know, the more I do it, it
Mhm.
makes sense.
Yeah. Testing. I think this is training. This is training and this is testing. I was confusing those testing. I have a feeling, okay, guys. Don't get me wrong, but I have a feeling you guys are not working very hard. you can correct me if I'm wrong, but I don't think you guys are working hard. I don't see anybody bleeding or crying. You guys are not working as hard as you should. This thing is painful. And that's just in a lighter moment. I'm not judging anybody.
Can we get another data set that we can use to practice on this one?
I'm gonna refer you to Joseph Omondi. This word one time. Remember?
Oh,
There's so many data sets out there. I don't have to
okay.
give you, but you can go to Kaggle, you can go to .com, you can go to ICU, I think one of the institutions in the West Coast, and you can even actually look on Google, just any data set. And then,
Okay.
yeah, you can even get your own data set. You can just create your own data set. Let's say we want to do, our next one will be natural language toolkit. We will do a data set, most likely on email spam.
Mm.
We do a data set which we are going to borrow, but you can do a data set which you can just create or you get from a computer. You know, every program, every legitimate program in the computer has its own logs. So like a good email system will give you a very good log. So how many emails came in, how many are spam emails based on, let's say, the subject or the content. And maybe sometimes even the time period when they come and at what rate they're coming. So we basically go and categorize them, and then look, and then train a machine to know that any other email coming in this pattern is going to be categorized as a spam email. So you can get a lot of data sets out there. Kaggle is one source. Data.gov, short for government, is another. You can go to data.world, it's also another. You can just Google ICU and then normally I put a plus sign and then I just say data sets. Boom, it's going to give you a range. Kenya, they also have some data sets. You can get those for rainfall, for stocks, for stuff like that. Okay. So we did that, and that's to do with the KNN. KNN is done. Okay. So we know KNN gave us 63%. We know the logistic regression classification gave us 71%. Now we are going to do the SVM. Esther, what's the SVM again?
I know it's called support vector machine.
The support vector machine, these are supervised. The supervised learning models with specific learning algorithms that analyze data classification and regression. This will be the most common data classification models we use. There are others too, which are out there. All right, so here, the SVM, right? What did I do? I probably compromised my code. Let's do it. Oh, that's SVM, right? Okay, so SVM. Oh man, I don't know what I just did. Did we do SVM with you, Emily?
I don't think so.
Okay, Emily, we did everything.
We did everything.
Yeah, and then I need to do a screenshot of all the results.
Oh, at the bottom of it.
Emily, come on, man. Okay, so measuring the accuracy of SVM, you don't want to do that yet. We are going to go ahead and do this part first. Okay, fitting the support vector machine to the training set right there. So we import SVC. We do the skyline. This is going to be a component of the skyline SVM. We do the classification. The model is going to be linear, like a line. Okay, random step of 1. We do the classification to fit the training and the X, and then the X and the Y. So we run that. Okay, so we get this. And again, if you want to know what all this means, just copy that SVC and then look on Google. It will take you to most likely their website, where it's going to break it down, the meaning of each. Now we want to predict the test results. So we run that. Whatever we are going to predict, we are going to take the X test here. Okay, X test, which is now a parameter, but we do the classification to predict, so we get the Y prediction. So we run that again, and then we go ahead and run this. Okay. We get the 1s and the Y. This is the 1 and the 0s. Most of them are 1s. It's a good thing. It's all true. But now let's measure the accuracy. If you do the accuracy, you just basically do this one, this function here, support, import metrics for Skyline, then you run that. But this one, let's see what's the difference between this. Import metrics, and then what was the difference between, this was Skyline of metrics, import metrics here. But this one is for metrics accuracy score. Okay, and then so here we are doing the same thing, but we are using a variable for the SVM. Okay, so here we are. It's very confusing, but this is all recorded. If you have time, you can go back and forth, compare this. So we run, we run this, we get the SVM. Now, as you can tell, the SVM is also 70 points. It's also 71%, which is pretty good and very close to LR. Okay, we do the confusion metrics. As you can tell, this is very close to LR. If you look at the definition, towards the end they say, here, they say data for classification and regression analysis. So SVM and LRM and LR are more or less in the same bracket in terms of what we are getting here. Okay, you can see the numbers. The percent is almost the same. The confusion matrix here is almost the same. So why do we even bother there? We just want to know. We want to know if LR and SVM are going to be close to each other. And yes, they are. So we guide and visualize the data set. Okay. So we run that. Should be faster. Get that. Okay. And then we do the visualization for the data set again. It's for the testing. The other one was for the training. Should be faster. You get that. Okay. And then, so this is just telling us this and that are more or less related. So that's it for SVM. Now the other part we are going to go ahead and do is the naive Bayes. That's the probability and the statistics involved. Mm-hmm. This one we'll get time and do it. Okay, in the notes, and then you'll be able to understand it. Like classifier. Now they say this is a simple technique for constructing classifiers, models that assign class labels to problem instances represented as vectors with picture values where the class labels are drawn from some finite sets. So Potena pattern, it's almost like karate. When you play, you either win or you lose it. Say you go to Las Vegas, you go to a casino. Most of those casinos, they run on the probability. They have they have algorithms which are running those machines. So most of the time, some people win, some people lose. Okay, is it going to rain or is it not going to rain? How is the weather going to be next week? Can we predict 4 days ahead of time, or can we predict 2 days? So you can use naive Bayes to help us do that. And naive Bayes has a very complicated algorithm which it runs based on the data set it gets in. We will be able to share that in the notes. So we have the classifier, which is Gaussian NB. NB is short for naive Bayes. And do the classification. Then we do the fitting for the training on the X and the training on the Y. Okay. To get this, if you want to know more, you can look that up. Okay. It's going to give you what the priors are and what the variable smoothing is. But if you for some reason you go online and you try to look, of course this will be in the notes, and you need any assistance in explanation, I'll be more than glad to assist. So we run that, we get this. And then now we can predict it using the classification model based on the X test. Okay, so we run that. Now we get the Y prediction. Okay, let's measure the accuracy. Look at the accuracy. It's even better. Actually, it's in the range of LR and SVM. Okay. So this is our accuracy. And then our metrics, this is probably what will set them apart. If you compare these metrics, the true positive, the true negative, and all that, you should be able to consider whether to pick this. There are so few true negatives. There are quite a number of true positives. If I was to choose the best model, I'll be concentrating on the true positives there to help me determine which one is the best. So for this one, I'll probably go pick the KNN. Is that right? Probably not. Let's see. 145. Confusion metrics, and that's for the SVM. This is going to be 100, and this other one is actually 143. So you're going to call the shots here. Whatever you want, that will go. Okay. So we do that, and then now let's go ahead and visualize the training set. Okay, as you can tell, quite a number of people fall in here. A few are falling outside here. So this depends on their credit history, depends on their income, depends on whether they're married or not, and also depends on their dependents and the loan amount. Okay. You want to visualize the test result now. After we do the training, the test here. Okay, if you compare that, assuming that this is your threshold, a circle, a lot of, not very many people, a lot of reds than a few greens out there. But if you look at here, the more greens here and just one red. So in this training, we have more people getting the loan outside the circle and few people, just one red dot. So that will also help you determine, okay, which model to pick or which classifier to pick. So we got that. Now we are going to go ahead and look at the decision tree classification. Remember, there's a big difference between a tree and a forest. Emily, do you remember the difference?
The difference of decision tree?
Between the decision tree and the forest.
The decision tree is it's like a loop.
Loop?
No, a forest is a combination of many decision trees.
Okay, yeah.
Is like a cluster of decision trees.
Yes. Okay. So when we talk of a forest, we're talking of so many decision trees batched together. But when you talk of a decision tree, it's just one single. So normally decision tree deal with just a small data set, but a forest will deal with a lot of data sets combined together. So if you're working on a very large data set, you probably want to go inside of random forest. But if you work on a small data set, you probably just want to do the decision tree. Okay, so here, so we want to fit the decision tree classification to the training set. So here we do the criterion of entropy. We do the random state goes to 0. As you can tell, I insist on the 0 here. Okay. If we run that, we are going to basically train this, and then we fit into the X train and X and the Y train. So we run that. Again, if you want to know all the meaning of all those parameters, just punch this in your Google, and it's going to give you all the definition of each and what you expect. And I really encourage you probably want to do that. Some of them are applicated, so some of them will come back with some features. And then here we want to predict the test set result. So remember, some of them we got before were a lot of ones. But right here, we have a lot of zeros, if you can tell, right? So that's something we need to take a note of. Okay. Now let's look at the accuracy. Compared to the other one, this is terrible. Okay? This is only at 54%. So if I was to make a decision, I will not go with the decision tree. The decision tree is only giving me about 54% accuracy. And then look at the confusion metrics. Okay? The true positives are just about 90. You know, because I really need more true positives to even decide. So here, that's not good. It's almost like spread out evenly. Okay? And then let's visualize it. Okay? So visualizing that, then we got that. Almost the map of Texas. Okay? So this tells us how many greens they're pretty much spread out. Okay? So this right here, Esther, is just basically emphasizing what you have up here. Confusion metrics and also combination with the accuracy. If you get this down good, accuracy, and you get the confusion metrics down good, you don't have to worry about this. This will just be for the management. It's basically explaining from a bird's point of view. I mean, from a bird's eye point of view, like from up above. Okay. Now we did the training. Now let's do the test set. Okay, now we got that. So this is a summary of what we got in the accuracy and what we got in metrics, confusion metrics. Okay. So we see that the decision tree is only giving us 54%. Not so good, but at least we know now. Okay. Now let's go and do the random forest. Now the bigger picture of what the decision tree is going to give us. So for the random forest, again, you can type this in, then it's going to give you all the variables. Use the entropy, use random state 0, estimation is 10. What did we use the estimation for here? One second. Putting the random forest, putting the decision tree. So here we don't have no estimation. Then in the random forest, we do. And then we also use the same criterion, which is entropy, and then use random state. So let's see what's the difference. Okay, so that's a big difference. Here, at least we have a range to work with. Estimate, we do the estimate, let's see, up to 10. So we run that. Yeah, now let's go ahead and predict the test results. Use a predictor. See, we also get quite a number of zeros and ones, almost like what we got in the decision tree. Now let's get the accuracy. It's not so good, but at least better than random forest. It's at 59%. Confusion matrix, it's a little bit again spread out. But we have true positive 98. Here we had true positive at 90. So if we were to be given a choice between random forest and decision tree, I would pick random forest. Okay. Okay, so here, let's go ahead and visualize this. Okay. Okay. Got that. Almost like what we got in the random forest in the decision tree. Okay. Let's go ahead and do the visualization of the test result. Almost the same. See, like a few people are actually being approved at this very high, okay, compared to what we got here. All right, so here we got it. Now look at the summary of the results. Okay, so this is your final analysis. And this and that are more or less the same. But I would probably go with this one. But again, if this one and this one are still the same, because it's all both at 71, but I'll probably go get 71%. So my choice will be this one for my classification. Okay. Now remember, okay, decision tree we did last time. We got this. Okay, we got a lot of visualization there. It's the same thing. This is the same data set, but just different way of doing stuff. Okay? Then we got the Emily. We got this together, right? Remember this?
Yeah. Yeah.
Then we also got this. So if you had what we just did and what we have right now, we combine both, give you a whole knowledge of even working at Central Bank of Kenya if you want to do predictive analysis. You can predict the weather, you can predict the stocks, but it depends on the data set. Okay. Any question before we proceed?
George, I think the only question I have is based on the previous that you just did, the one you just did. Okay. How you were able to do the visualization, how you came up with some of the visualization. I think you said you did some averages. Okay. I think it's on the previous file you were looking at.
Okay. This, I'm not sure if I say the average, but these are models, right? So we use a model to. Okay, let me go back. Is that the one?
Yes, I think that's it. Yes,
Really?
I think that's one. Yeah, just the visualization part.
Yeah, but this doesn't have no visualization. I think I have like 4 of those different angles.
Oh,
One second.
okay.
Let me open this one. Okay, loan prediction, loan analysis. For the visualization will be pretty much standard. Not this one, right?
No, not this one.
Let me see if I can go back because it keeps on overwriting what I'm looking for. I need to give them different names. Okay, loan prediction. Loan. This is the one. That's not the one. Let's see. Yeah, I opened so many tabs. Because I have to multitask. So that's a dictionary. Bear with me. Loan approval. That's the same loan approval. Do the loan prediction. This is the one, right?
I think this is it. Yes.
Let's go back and load the data set. So one. So allow me to load this so we can get it all together.
Okay.
See how lambda is being used here. Lambda is important. So I need to run all this one by one so we have to clean that. I'll split the data set. Get the X, get the Y, split again, training, get the X, and code, hit when it does that. Let's see 1 second. Let's view it. fix it. Some number up here. Yeah, it's very involving, right? That's it. Cool. See how sometimes you have to run it all the way from top to get the variables you need to use in here, Emily.
Yeah.
Scaling, component analysis. Let me know where exactly you want it to be, Joseph. This,
Yeah, I think it's close by. Yeah.
let me show you my case, matrix.
Okay, so right there. So basically, yes, I just want to understand this part here.
Okay. The whole of this, or just like?
I'll say, let's say from line, let's do line 2 to about line 9.
Okay, so here we want to visualize the training set, right? So we import the matplotlib. Okay. And then we do the colors. Import the listed color map. Okay. And then we do the X test, X set, Y set. Remember this will go into that will go into this. And then X1, X2, NumPy, okay? Dot, you do the mesh grid. Okay? It explains what the mesh grid is going to be here. Okay? And then we do the NP arrange, dot arrange, and then we do that arrange. That's a function. So we start from X set, which is this one, right?
Mhm.
Then we call something we call in list as slicing. Remember slicing?
Yes.
That from this here, we go the minimum. It's a minimum function. And then we stop at except at that. So this one is going to be like you go maximum, you add 1, then you do step 0. Some of these are very nitty-gritty, but if you want to get more about that, then you want to go into here. It's going to explain each and every parameter for you.
Okay.
Okay.
Yeah.
And then once you get that, you do the same, whatever you did up there, you do the same with this one. If you look, the one up at the top and the one below it, it's just the difference, it's maximum and minimum. I mean, maximum and stop. X, it's all the same here. And then you do the plot. Remember, when you do the matplot live, you also imported a PLT. So you get contour, okay? And the contour, if you see here, it's going to be the X and the Y, okay, which we have to pass in as a parameter. And then you get the levels. Now remember what Monica talked about yesterday, the functions. If you're not sure what you're going to import a number, then you probably want to give it that wildcard.
Right.
You do the contour, you draw the contour lines, and you fill the contours respectively, except as noted here. Okay. So if you were to scroll down, this gives you everything. I know you are a PyCharm guy, but you want to do this on your own. So it's going to give you pop-up on all the examples and explanations. See that?
Okay.
Just like if you did that to give you all the even examples and explanations. Now, once you get the contour, now you are going to go ahead and do this. This returns a tuple of the new x-axis limits, which is x underscore x alignment. This one. Look here. Okay. And then this will plot the y. So this one will plot the y-axis for you. And then it also gives you the information. So the bottom, top equals ylm, and then ylm pass a function, bottom, top, set the ylm to bottom, top, set the ylm to bottom, top. So if you do not specify the arguments, you can alternatively pass a button or top as a quarks here. If you look, we did that. We did the quarks. Okay. Now, once you do the plot, now you are going to go ahead and declare a for loop. The for loop here will be with two variables, the I and the J. The numerate is a numerate, and it tells you what the numerate object is. And then you call np.unique. And remember, this, whatever you see here, this could be something you actually adopt from some of these examples. You don't have to know it all.
Yeah.
Basically, by this example, some people have already worked in these functions. You just want to adopt them and work with them. And then, now once you do that, remember the for loop. Now we go and do the scatter plot. The scatter plot also explains to you. Also that scatter plot, the parameters, everything. The matplot live, everything. Okay. Once you finish that, now you declare in that scatter plot, I want it to be called this title, the logistic regression training set. And then I say, whatever that color, make it red and green for those data sets. And then I put the label. You can change this label to anything you want, so long as it's descriptive, the Y and the X. And then you do the legend. When you do the legend, this will be the legend, and this will be the legend, and this will be the label, and that will be the label for the X and the Y axis respectively. Now, when you do the plot, you pass the function show. Now show it. So it's showing us what is displaying what we need to see. So this will take you some time. Get different data sets and work on those. Just make sure whatever the biggest difference will be here, whatever you train in. And remember, this did not come naturally. We got it from the split, where we did the splitting. Like where do we do it? When we do the classification, we still got it from the splitting. We do the splitting up somewhere. Here we're just applying it, but we need to go back to where we did the splitting, the data set splitting. Where did we split that? Right there. This is where you did the split. Once you do your split successfully, now everything up down there will be following these variables. The split has to take X train, X test, Y train, and Y test. And then you call the function training test split, X, Y, test size. If you say test size, the test size will be the amount of data you want to apportion to the test side. If it's 100, then 1/3 of 100 in this case. Most of the time, you want to treat it as 100%. So either take 20 and 80, 30 and 40, 30 and 70, 40 and 60, but you don't want to make it too small. Okay? So that's how you probably come up with something like this. But this is your crown jewel right here. And the rest just plug in.
Okay. Yeah, that makes more sense, yes.
So don't think you are required to come up with the whole shebang. You're training that.
Yeah.
Okay.
Okay.
Any other question?
I think I'm good on that. I'll just look more into the mesh grid and probably just work on it and see how I come up with it.
Yeah, I highly recommend doing that. Practice makes perfect. If you visualize these data sets, you will not get any difficult in terms of any kind of work you get out there. So if you understand, let's say this, it gives you everything you read. These are some of the things which, when, let's say you go for an interview and they ask, they'll not be asking you a lot of questions, but they just might be asking some of these very obvious things you've been dealing with. You know? They can ask you, let's say, what's Kenya, how is it related to maybe other classifiers. Don't say you like one over the other. That depends on the data set. That depends on what kind of model you're working with. Yeah. Any other question? How do you feel? How do you feel about this whole thing?
I feel much better for me.
Okay.
Okay.
Very nice. How is everybody feeling? I don't want anybody to be left behind.
I feel good as well. I guess just like you said, like everything you do, like there's different variations that you do, just the way you've shown on here, like you have different files that have different ways that you are able to plot them and all that. So I guess it's just a matter of understanding the data set and trying to figure out the best classifier that you can use on there. I mean, the best algorithm that you can use.
So for example, right now you can go back to your COVID data set. Remember the one you worked on?
Yes.
You can do different models with that.
Right.
So you just make sure you clean it. There's a lot of zeros in there. Make sure they're filled in. And then try them out. understand, and the biggest part you need to understand is how to use and split your data sets. Everything's available. You just have to be able to acknowledge that they are out there and you can look it up. If you don't understand it, my number is the same. Just reach me.